Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashidu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Site-Bono Discovery Center. So we'll be starting with our lesson for today. We're going to focus on term 3 content. I think you have been busy with this, or you are busy completing this topic. So it's very much important. Electrochemistry will be doing galvanic cell today. Now, you will remember paper 2. You have two knowledge areas there, which is our matter in materials and chemical change. You'll remember matter in materials here. We are referring to your organic molecules. We are referring to your semiconductors. So that is your matter in materials. And then that matter in materials carries 47 marks, which is 62% of the paper. And we have chemical change, which carries 28 marks. This section that we are doing today is 28 marks, and that is 38% of the paper. Remember, paper 2 is out of 75 marks. You are going to be writing on the 26th of September for 1.5 hours. So we are saying the weighting there, the levels to say 30 to be level 1 questions, that your recall questions, kind of questions, you'll get 30%, your comprehension 35, and then your analysis 30, and then your evaluation type of questions 5. As indicated there. So this is the structure of your paper 2. So please don't forget, paper 2 is 75 marks. And of those 75, 28 will come from this section that we are busy with, which is called chemical change. The focus for today is galvanic cell. Now, this is the diagnosis for previous years to check how learners are doing the topic. So we are fairly not doing very well in this topic, but it's not a difficult topic. I'm hoping that what we're going to do today is going to simplify the topic so that you can collect as many marks as you can. Remember, out of 75 marks, if you can get 40, you have passed very well that paper. So we're expecting that a minimum of 28 marks of chemical change, you must be able to get 25 at least. So as indicated, we have 3 units of this chemical change. It's electrolytic cell, it's galvanic cell, and alternate energy. So today we are focusing on galvanic cell. Now, you will understand that you have done from grade 8, grade 9, grade 10, you've been doing the periodic table. It's very much important for you to understand the periodic table. Now, how is the periodic table going to help us in terms of this topic? You will see that in our periodic table, we have groups here at the top. We have group 1 there. You can see that is group 1 elements, where we are having our alkali metals, which is your lithium, sodium, potassium. Those are the most important ones in that group 1 elements. As well, hydrogen falls into that category. We have group 2 elements, which we have beryllium and magnesium, and as well as calcium. And then we have all these metals here. So you can see that on the left of this periodic table, we have group 1 metals, group 2 metals, and the metals in the middle here, we refer to them as transition metals. So we have transition metals, and then we are able now as well to have what we call semi-metals. Semi-metals, you will have done these ones when you're doing your semiconductors at the beginning of the year. And then from there, when you go to the right, you have what we refer to as non-metals. So you can see that our periodic table is arranged in such a way that metals are on the left-hand side of the periodic table and non-metals on the right-hand side. It's very much important for you as well to understand that we have group 18 elements which are fully filled. So these ones, you see that they are unreactive. So these are, we refer to them as noble gases. They are unreactive because they are fully filled. So the reason for reactions to take place is that all of them, these elements that we have in the periodic table, they would like to behave like our noble gases or group 18 elements. They all want to be fully filled. Now, this topic that we're going to deal with is mostly about dealing with the issue of loss of electrons. Remember, we're referring to this topic as redox reactions. So the type of reactions that we are having there is a redox, which is taken from the word reduction and the word oxidation. So when you combine the two, we are saying redox reaction. So I will be referring to reduction, I will be referring to oxidation. As the name says itself, when you say reduction, you are expecting that what we refer to as oxidation numbers, they are going to decrease. When you say oxidation, the oxidation number will increase. You will see that For example, the group 1 elements. Group 1 elements, they have a tendency of losing one electron because they only have one electron in the valence shell. So it's very much important for you to understand that the metals, they can easily lose the electron because the electron is not tightly bound to the nucleus or to the structure itself. However, the non-metals, they are more electronegative, so they have a tendency of gaining electrons. So under normal circumstances, you will expect a metal to lose electron, a non-metal to gain electrons. For example, when you are using sodium, for example, as a metal, sodium is a group 1 element. Sodium can be able to lose one electron. Then if it loses one electron, you see the loss of electron. I'm writing the electron on the other side of our arrow there, and this will refer to it as loss of electrons, which we are going to give it a name to say is oxidation. I will be explaining why we refer to it as oxidation. So this is loss of electron. We're going to refer to it as oxidation. So we're saying these metals, because they have valence electrons or electrons in the outermost energy level, they will lose that electron, and when they lose that electron, their oxidation number increases, and the process is referred to as oxidation. You will see that our metal that I'm using as an example, sodium, it has no number here. It has an oxidation of 0 there. But when it loses an electron, its oxidation number increases to 1. So you can see that when a substance loses an electron, its oxidation number increases. Hence, we refer to the process as oxidation. But for example, if we bring chlorine, which is a diatomic gas, Cl2, if Cl2 gains electrons, it will gain 2 electrons. Remember, chlorine is a group 17. So group 17 elements, they have a tendency of gaining electrons, but because they are running short of only one electron to be fully filled, to behave like argon, for example, chlorine, it wants to behave like argon, which is fully filled. So if it gains one electron, chlorine becomes now fully filled. In this example, chlorine will gain, because we have 2 chlorines there, they will gain 2 electrons, and they will now become 2Cl minus. I want to demonstrate to yourself that this is referred as reduction. So I want to show you why we say gaining of electrons is reduction. So you will see that on top of this Cl2, there is nothing. The oxidation number there is 0. But when chlorine gains 2 electrons, Cl2, when it gains 2 electrons, its oxidation number becomes minus. So you can see from 0 to minus, that is a reduction. Hence, we refer to gaining of electrons as reduction. So I would like you to always remember these mnemonics that I'm using here, because they're going to help you to remember the definitions. Remember, all the questions, they are starting with definitions. We have definitions in all the questions that we are having. If usually paper 2, we have about 6 questions, you will find that all of them, they have a question that says define. So it's very much important for you to understand that when we say loss of electron is oxidation, so oxidation number increases. When we say gaining of electrons, the oxidation number will decrease, and we will refer to that as reduction. So we're saying when you gain electron, remember electron is negatively charged. So when you gain a negative, definitely you become now a negative now, because you are gaining a negative, an electron which is negative. But when you lose negative, you remain positive. So it's like when you have a friend and then you lose a negative friend, you become a positive person. So that's the same thing we're saying here. We're saying when sodium loses electron, which is negatively charged, it will become a positive, and that we refer to as oxidation. But when you gain electron, which is negatively charged, you will now undergo what we refer to as reduction. I hope I have tried by all means to make you understand the difference between oxidation and reduction. So we are saying oxidation is loss of electron. Why is it oxidation? Because you are losing an electron which is negatively charged. So you are becoming positive when you take out negative. But when you gain electron that is negative, you are becoming more negative. Hence we call that reduction. So you will always remember, we're saying Leo, which is loss of electron, is oxidation. Gaining of electrons is reduction. That is my introduction, and I hope it will help you. Now, in lower grades, I don't want to say only in grade 10, but in lower grades, you have done what we refer to as elements, as early as grade 8. We have done the elements, and we said the elements are the ones that you find in the periodic table. They are substances that cannot be broken down. For example, if you go to if you have sodium, for example, you can't break it down because it's only one sodium. You can't break it down into simpler substances. And you have what we refer to as compound. So a compound consists of two or more elements. So when you join two or more elements together, it's now referred to as a compound. And then we have done as well what we refer to as naming of this compound. You know, the charge of simple ions. As I indicated in our predictable, to say we have group 1 elements, where I have demonstrated to you using sodium. So sodium, because it's a group 1 element, it can lose 1 electron. So I've shown you that sodium can lose 1 electron because it's a group 1, and when it loses, it gains the charge of positive 1. You see where that positive 1 is coming. This charge of positive 1 is because group 1 elements, they have a tendency of losing 1 electrons. Now we have group 2 elements, which we find there for magnesium. So magnesium can lose 2 electrons. So when you have magnesium, you know that magnesium can lose maximum of 2 electrons because those are valence electrons. It's easy for these electrons to be lost because they are not embedded in the structure. So we are saying group 2 elements, they will form a charge of +2. So it's very much important for you to understand, because when you see, for example, magnesium sulfate, MgSO4, you will be able to know that magnesium is a group 2 element, which means it has a charge of +2. And the other thing that I want to emphasize is that when these metals loses electrons, like group 1 elements, they have a +1, group 2, a +2, group 3, where we have aluminium, for example, aluminium will lose 3 electrons. So aluminium can lose 3 electrons. These, now, when you go to group 14, you will find that these group 1, 2, and 13, these groups 1, 2, and 13 that I've talked to, they are metals, though they have a tendency of losing electrons. But now, these metals, they are good conductors of electricity, or because they have between 1 and 3 electrons in the outermost energy level. I talked to that as well, to say group 1, they will lose 1 electron, group 2, they will lose 2 electrons, group 3, they can lose 3 electrons. Why are they losing these electrons? Because these electrons are loosely bound, so they're not holding tight to the structure itself. But when you go to the non-metals are poor conductors. They are poor conductors, meaning that they contain the valence of between 4 and 7 valence electrons. For example, we have these electrons are firmly bound. They are holding on to the structure. So it's not easy for a non-metal to lose electrons. Hence, if you have a non-metal reacting with a metal will lose electron, a non-metal will gain electrons. I gave you an example with sodium, to say sodium can lose electrons and chlorine can gain electrons. So sodium is a metal, it loses electrons. Chlorine is a non-metal, it gains electrons. Then it forms 2Cl-. Then you are able to balance there. You will get that sodium chloride is formed, which is our salt now. That's our salt. So this is an ionic compound. We have sodium plus and 2 chlorine minus. Then these are able to form our sodium chloride. Now, the other thing which is important is that these non-metals, we are saying they are insulators. Insulators, it means they are not good conductors of electricity. Now, an exception to the general rule is that of carbon, which we refer to as graphite. You see, carbon is a non-metal, but it's a good conductor of electricity. So it can conduct electricity, though it's a non-metal. So it's an exception, this carbon. Hence, this is the graphite that is used even in your pencil. So you have to know carbon is very much important. You will see when we do other sections, like electrolytic cell, we'll be using carbon because it's a good conductor of electricity. So I wanted to take you back to say you're not doing this section for the first time. This is the information that already you know. You know the elements from the periodic table. You know that there's a compound that when you have more than one element joined together in a specific ratio, they are able to form a compound. You know how to form them. Now I've demonstrated to you that group 1, they will lose 1 electron. Group 2, they will lose 2. Group 3, they will lose 3. Why are they losing? These electrons are loosely bound. They are not holding tight to the atom itself. Now, group 14, where we have carbon, we're saying carbon is a good conductor. Though it's a non-metal, but it's a good conductor of electricity. But if you look at from group 15, 16, 17, I hope learners, you have your periodic table next to you. You are looking at the table as I'm indicating, so that everything you are doing is in the periodic table. Now, group 15, group 16, group 17, you can see saying -3. Why minus? Because they are gaining electrons. Remember when I indicated that when you gain electrons, like with the case of chlorine, when you gain electrons, you become negative. So you can see that group 15, because they are holding on to they gain electrons. So group 15 can gain 3, group 16 can gain 2, and group 17, where chlorine is, they can gain 1. We wrote 2 here because we have 2 chlorine, but each chlorine will gain 1 electron. I hope you understand that. So group 18, we said they can't gain, they can't lose, because they are fully filled, they are unreactive, they can't react. So this is the foundation that we are bringing into this section, and I hope it will help you. Now, without wasting time, we move. These are the definitions that in grade 11, you have covered this majority of this definition. The first one is the one we've been busy with. I think we are done with that one. We said loss of electron is oxidation. So in the exam, you'll get a question that says define oxidation. So you will be able to say this is loss of electrons. I use sodium as an example to say, okay, sodium can lose electrons, and that will refer to as loss of electron. When the oxidation number increases, then the process is called oxidation. What is oxidation? It's a loss of electron. So I hope you understand and remember that definition. Now we have our second definition now, which is reduction. Reduction, we said, is gaining of electron. It's called reduction. We use the example of chlorine, our Cl2, gaining 2 electrons to form 2Cl minus. Just bear with my writing. I will write it here. We are saying reduction is Cl2 gaining 2 electrons to form 2Cl minus. So we say gaining of electron is reduction. So don't be confused to say you are gaining, but we are saying it's reduction. You are gaining an electron, and electron is negatively charged. So you are gaining negative, hence you are undergoing reduction. But when you lose electron, which is when you lose negative, you are undergoing oxidation. So oxidation simply means the increase in the oxidation number. Now, there are other terms that we're going to be talking to, which is your anode, which is your cathode, your reducing agent, your oxidizing agent. You have done this in grade 11. However, we're going to go through them so that you remember all these definitions. Remember, I've been talking to the oxidation number. I said the oxidation number of sodium, when it's on its own, is 0, but when it has lost electron, the oxidation number becomes positive 1. So that is the oxidation numbers that we are talking to. You have done electrolysis in grade 11, electrolysis of copper chloride solution. You have done that in grade 11 as well. However, it will be covered here. The focus for today, it will be galvanic cell. Now, I've talked to these definitions, but for you now to remember, we're trying to make everything easy for you to remember. As you'll be sitting for your exams, you must be able to remember these terms. So what are we saying? We're saying, remember, loss of electron, we said, is oxidation, and that is your reducing agent. So the substance, a reducing agent is a substance. Don't forget, I'm saying a reducing agent is a substance that does what? That loses electron, or that undergoes oxidation, or that is oxidized. So you will remember that definition. We'll talk about these reducing agents. And then, hence, I've defined for you what is loss of electron. We said it's oxidation. What is a reducing agent? We're saying it's a substance that undergoes oxidation. What is your oxidizing agent? This one now, it will be oxidizing agent, say substance that undergoes reduction. And then we have an anode. Anode, you can see, is taken from the word electrode. Electrode. So you can see anode is the electrode where oxidation takes place. To remember, you can say an ox. So you know that at the anode is where oxidation takes place. At the cathode is the electrode. So you will start with the word electrode, because the cathode is the electrode where reduction takes place. So you can say red cat. for you to be able to remember these definitions. So spend some time revising these definitions, because definitely you will get them in your paper. Now, this galvanic cell that we are going to talk to today is just for us to say, what is galvanic cell? The first thing that you must know is the definition of galvanic cell. Remember, what I was talking to is what you have covered already in grade 11. Now, in grade 12, the new information is for you to say what is galvanic cell. So I'm saying galvanic cell, obviously galvanic cell is a cell. This cell converts chemical energy to electrical energy. So we start with chemicals, but we are ending up with electrical energy. This cell is spontaneous. What do we mean by that? We're saying there is no energy that is added. Instead, it's exothermic, which means it takes off energy. Energy is being released. It releases energy. Hence, it converts chemical energy to electrical energy. So this is very much important for you to remember. Number one, we're saying you must know the definition of galvanic cell. We're saying galvanic cell is a cell. So the main thing that you define the cell is based on energy conversion from chemical energy to electrical energy. Please don't forget galvanic cell. We can call it galvanic, or we can call it voltaic cell. So we use the words as and when interchangeably. We can say galvanic cell or voltaic cell. So we're saying galvanic cell, energy conversion is from chemical energy to electrical energy. I hope you will remember that. And we're saying this is spontaneous and is exothermic. This is just brief history that we just added for enrichment. We won't be asking you where galvanic cell is coming from, but this is just to say that this is named after Luigi Galvani, who is the one who came with the galvanic cell, and Alessandro Volta, hence we call it voltaic cell from his name. It's an electrochemical cell in which electric current is generated from spontaneous redox reaction. But the main thing for you to remember from this page that I've given you is the definition. What is galvanic cell? We're saying it's a cell that converts chemical energy to electrical energy. And we're saying this cell is spontaneous, which means no energy is added. And we're saying energy is released because it's exothermic reaction. It's like when you say somebody is spontaneous, you're saying they can do things on their own. They are not supposed to be pushed. So that is the same thing we're saying here. When we say this cell is a spontaneous cell and is exothermic, is able to release the energy. Now, here is a typical example of a galvanic cell. Now, there are apparatus that we use. I hope you have done, or you are busy doing the experiment on the galvanic cell of magnesium sulfate, magnesium and copper, where you're using magnesium sulfate and copper sulfate as your electrolyte. So this is the type of cell. It behaves the same as the one that we are doing for your pet for this year, hoping that even this, it enriches your understanding of the topic. So we're saying for this cell, we need two beakers. We don't use one, we use two different metals. For example, the two metals we're having the zinc and the copper. So those are the two metals, and they're each immersed in separate beakers. Hence, I said we have two separate beakers and then containing their respective metal ion. What does that mean? It means if you have a zinc, you can't put copper solution here. If it's a zinc, the solution would be zinc sulfate. You can use any electrolyte spectator ion there, like you can say zinc sulfate, zinc nitrate. There's nothing wrong with that. You can say copper, then it must be in a copper sulfate or a copper nitrate. So that is your solution that you are using. Then we have what we refer to as a Sol bridge. We have now the voltmeter there as well. So you can see that these are important components of what? Of a galvanic cell. So what do we need? We need two different metals. In this case, our metals is zinc and copper. But we are saying they must be in two different beakers and they must have their own metal ions. So we can refer to zinc sulfate, as I indicated to you. We can refer to zinc sulfate as zinc 2+, and we can refer to copper sulfate as copper 2+. So I don't want you to be amazed. Maybe you go to the exam room, the solution now is no longer given as copper sulfate, and you think that the question have changed. No, it is still the same question. What are we saying? We're saying if you have zinc, it must be in a zinc sulfate, or zinc, the ions that it has must be zinc ions. So we have copper and the copper 2+. So what you must have to understand is that our electrode here is solid, and our solution here is aqueous solution. So we have aqueous solution and a solid. So it's a solid immersed inside an aqueous solution. That solution we refer to as electrolyte. So it's very much important for you to remember that these solutions, which is your copper sulfate and your zinc sulfate, we refer to as electrolyte. So we're saying you have two solids, your zinc and your copper, they are immersed inside the electrolyte. But the electrolyte must be made up of solutions of the same metal. The metal must be there. So it must be a metal ion. So it's zinc and zinc inside zinc 2+. Is copper inside copper 2+. So these are the minimum requirements, apparatus that we have for a galvanic cell. I hope you understand that for us to have a galvanic cell, this is what we must have. So this slide is meant for you just to understand what do we need for a galvanic cell. Remember, in other questions, we also ask you to draw this galvanic cell. So you must know that you are able to draw a bigger and another bigger. You are able to immerse a metal and the metal ion, and another metal and metal ion. Then you have the conducting wires that you connect through the voltmeter, and then you connect the two, and then you are able to have all your structure there given. So I won't be talking to the operations, how this galvanic cell work on this slide. I just want you to understand that this is the components that we need for a galvanic cell. Now, without wasting of time, now we are going to go to the process itself to say what really happens during this galvanic cell. Now, you will remember when we started this topic, we said we have sodium, which is a metal, it will lose electrons. We had chlorine, which is a non-metal. We said non-metals, they like to gain electrons. Now, the same thing is supposed to happen here, but our issue here is that we have a metal, zinc metal is a metal, and we have another metal, which is copper. So it's a metal and another metal. It's no longer easy now to say who is going to lose electron, who is going to gain electron. It is easy when we have a metal and a non-metal. But in this case, we are having a metal and a metal. So we must come to a discussion to say who is going to lose electrons between a metal and another metal. In this case, between zinc and copper. Who will lose electrons? Who will gain these electrons? Remember, these two reactions take place at the same time. So I hope you are following me on that one. Now, we have metal is zinc. We have another metal is copper. What do we have as well? We have zinc sulfate. I told you already that sulfate is just a spectator ion. Zinc sulfate is the same as zinc 2+. And then this is copper 2+. If I remove the SO4 2-, which is our spectator ion. So we have zinc inside zinc 2+ solution. We have copper inside copper 2+ solution. Now the question is, how will I know who will lose electron, who will gain, or which metal will lose electron, which metal will gain electrons? Now we have a table I've taken. I will advise that you use table 4b for table 4b of standard reduction potential. You use it for galvanic cell. So I will advise you that galvanic cell, please refer to table 4b. Remember, you have two tables, table 4a, table 4b. They are the same tables, but with different entries. If you look at table 4a, you will see that it starts with the positive numbers going to the negative numbers. But table 4b, like I've taken a screenshot, a small copy of that table there, just to deal with our case here, to say, look at this one, it starts from negative numbers going to positive numbers. You will see this table is the one that's starting with the lithium and all that. So this is the table that we'll be using for galvanic cell. So I hope you are opening, as we speak now, you are opening your table 4b, because we're going to do this activity together and see who is going to lose between zinc and copper. Which one? Because one must lose electron, the other one must gain electrons, and they are both metals. Now, if we look at the table now, you will see that we have zinc, because we are looking for zinc and zinc 2+. So it's important that when you go to the table, you go and look for zinc. Here's zinc, which is the same as this one, and zinc 2+, which is this one. So it's very much important for you to know that when it's a sulfate like that, it's a 2+, so that you are able to know that, okay, we have zinc and zinc 2+. You go to the table, you look for zinc and zinc 2+. So you got them, you say zinc, I'm done with it. Now let's go to copper. We're looking for copper and copper 2+. So we do the same activity. We go to the table, we look for copper. Be very careful, because if you look at this, we have a copper plus here. And in the diagram that we are given, we don't have a copper plus. So you can't choose this one as part of our question, because our question is between copper and copper 2+. So you must be able to look in the table for copper and copper 2+. You see, the correct copper that we are looking for is the copper that has a copper and a copper 2+, a zinc and a zinc 2+. I hope now you understand how to go about to the table for B to look for what you are given in the question. And this is the same strategy that you will be utilizing to answer this question. I hope it helps you and you are following to say this is how this table is going to go about helping yourself. Now, if I can continue on this one, so is to say, okay, you have zinc here. I'm underlining it. It has standard reduction potential of minus 0.76. Minus 0.76. Let's look at copper. We said the correct copper is this one. It's copper, this one. And then what is the standard reduction potential? Is positive 0.34. I want you to understand the meaning of these numbers, because they are not just numbers. We refer to them as standard reduction potential. So look at this. We are saying between zinc and copper, one must lose electron, one substance must lose electron, another one must gain electrons. And we might want to make a decision to say who is going to lose these electrons, who is going to gain these electrons. Now, let's talk. We said electrons are negative. So if you look here, you can see that zinc is negative 0.76. The standard reduction potential is negative 0.76. And copper is positive 0.34. So you know that the one who possesses, or the one who has electrons, is the one that is negative. Remember, you can only give what you have. Now, because zinc is negative, we expect zinc to be the one that will lose the electrons, so that copper that is running short of electrons, because it's positive, it can gain those electrons. I hope you understood that, but I'll be giving you other strategies as well to say, how will I know which one will lose electron and which one will gain electrons? Hence now, here we're saying zinc, this one, zinc. Instead of, because this table, if we look at this table, the electrons are on the left, which means all of them are gaining electrons. Hence, the table is referred to as standard reduction potential. Why reduction? Because all of them are gaining electrons. And we're saying during redox, one substance must lose electron, one substance must gain. So already the table is saying all of them are gaining. So we're supposed to come to a decision to say who is going to change, who's going to lose electrons. Hence, what happens is that zinc, the negative electrode, is the one that is going to lose electrons. Meaning that if it loses electrons, it means now we must write the zinc going backward. You see, hence we start with zinc, it loses electrons, it becomes zinc 2+ plus 2 electrons. Copper 2+, we're going to write it the way it is written here. So we change nothing. We simply say copper 2+ plus 2 electrons forms copper. But the difference is we no longer use 2 arrows. Please, 2 arrows means we have 2 reactions. Now we're going to have 2 half. Hence we're saying this is a half reaction, oxidation half reaction. This one is a reduction half reaction. So in your books, we don't ask you questions to write double arrows. You only write one arrow, one for oxidation half reaction, the other one for reduction half reaction. So I'm saying zinc, because it's negative, is going to lose electrons, which means we'll reverse it. We'll start from zinc, forming zinc 2 plus 2 electrons. I hope you got that. Copper 2 plus, because it is a higher standard reduction potential, it will gain electrons, meaning that we'll write it the way it is, but we are no longer going to write 2 arrows. We write only 1 arrow. Remember, you are able to get this question and then you will get your 2 marks. We'll say, write down oxidation half reaction. You say for oxidation, for losing of electrons. Remember we said this is loss of electron, which is oxidation. So when you say oxidation, we're saying who will lose electrons? We're saying the negative one. Because electrons are negative, the negative one will lose electrons. The positive one will gain electrons because it's electron deficient. I hope that helps you to determine how to know which one will lose electron and which one will gain electrons. So this is what we will come up to. Now, as I move forward, I would like to say we have these tables that I'm talking about. The table of standard reduction potential is very much important. I refer to it as a memorandum for this question, to say you have a memo. We have 2 tables which are similar, but the entries are already in opposite direction. I've told you already that the other one starts 4A starts with positive numbers, to positive standard reduction potential to negative standard reduction potential, but 4B starts with negative, which is our anode. We said the negative is the one that is going to lose electrons, because negative shows that it has electrons, because electrons are negative. Now we are saying now the table of standard reduction can be used for the 4 things here that I've written for you. The question can say which one is the oxidizing agent, which one is the reducing agent. So we can use that table for that. We can use it to identify the anode and the cathode. The anode and the cathode, we can use it to write a balance redox reaction. And number 4, we can use it to say whether the reaction is spontaneous or not. So those are things that we can use this table for. So we'll be doing it practical so that you are able to do all this. Hence, I have this table here. If you look on your table that you are having, you will see that on your left, you have an arrow that is pointing downwards. It's written increasing oxidizing ability. Increasing oxidizing ability. It's written like that. Then you have another arrow on the right which says increasing reducing ability. So it's important, increasing reducing ability. Hence, I wrote here. It means as you move down here on the left, remember, it means the oxidizing agents are on the left. These are the oxidizing agents. And as you move, their strength increases. So it means copper 2 plus, for example, the stronger oxidizing agent, right? Hence I wrote SOA there. Don't write SOA in the exam, write it in full to say copper 2 plus, it's a stronger oxidizing agent than zinc 2 plus. And when you come on the right of the table, that's where you find your reducing agents. So now, if you look, remember a reducing agent, obviously its job is to reduce. So it must be negative. If you are an agent of negative, you must have negative results so that you use it to reduce others. Hence, we are saying a stronger reducing agent is zinc here. So on the right here, you see, mostly on the left we have ions, but on the right here we have reducing agents. So our reducing agent is your zinc. So if you were to talk between zinc and copper, you will say zinc is a stronger reducing agent, but copper is a weaker reducing agent. I hope you got that, and I don't want to spend much time on that one. Now, when you are given a question, you will be able to say, okay, the first one, there is this method that we use. You can write Z there. You can write Z between these two given. You write your Z there. What you have to understand is that the first one, which is the negative one, it will now be our anode. And then the positive one, which is copper in this case, will be our cathode. So you know, as we go down there, we're going towards the cathode. As we go up, we're going towards the anode. So you will see that our anode are on the right hand side. The anode and the cathode, they are on the right hand side of on the product side. Zinc is our anode. Copper is our cathode. Copper is our cathode. Now, when it comes to agents, I said oxidizing agents, they are on the left. Reducing agents are on the right, so that you don't have a problem with that. So when you write this reaction, you will be able to say, okay, for zinc, the arrow is facing backward. So zinc will be always come from to be zinc plus 2 electrons. For copper, you will write it as it is, copper 2 plus 2 electrons becomes copper. So I hope you understood that, to say it is only the smaller one that is going to be reversed. But the larger number or the higher standard reduction potential, you will write it as is. So you will write them like that. The first one, we said when the electrons are on the right, we call it loss of electron, which is oxidation. When they are on the right-hand side, we call that gaining of electrons, which is reduction. I hope you got that one, to say, okay, on the anode side, we have loss of electron, which is oxidation. On the cathode side, we have gaining of electrons, which is reduction. So you are able at all times to remember that, okay, on the anode, to lose electrons. Cathode, there will be gaining of electrons. Now, if you are to make a line there, for example, you make a line there. So we're using that Z method. We're writing that Z, and the Z indicates that this one will reverse. The first one always reverse. Remember, the mistake you must not make, you are using table 4b. So we're saying the one at the top of the table, because it has a what? It has a lower standard reduction potential, it will lose electrons. But the one with the higher standard reduction potential will gain electrons. Hence, we're saying zinc, it will lose electrons, it will reverse. But copper 2 plus, will write it as is. Please, you have to practice this one. If you understand the 2 and 2, they are equal. So if they are equal, the other one is on the product side, the other one on the right-hand side, so you can cancel the electrons. Remember, you only cancel the electrons when they are equal. What is on the left, you write on the left. What is on the right, you write on the right. So you have zinc 2 plus copper on the right there. Then you had zinc plus copper 2 plus, forming zinc 2 plus copper. So this one is what we refer to as your overall or net cell reaction. So you can call this net. Net means add together. Remember, we have two halves: oxidation half reaction, reduction half reaction. When you add them together, you have what we refer to as net cell reaction or overall cell reaction, which is what we are having there. You will see we're going to do questions. You'll be able to remember and see when you practice what we are referring to here, which is covered. Now we are saying this is our net. This question will have 3 marks. 3 marks. Remember, you have 3 marks there, so you have no challenge. The marks are you are collecting marks. For writing the oxidation half reaction, 2 marks. For writing the overall, when you add the 2 halves by first cancelling the electrons, you are going to have your 3 marks for writing the net. From there, remember we said to get to here, we said the first one is anode. The bigger number there, which was our cathode. So you have to know that. That is our anode and cathode. So when you have anode, there will be loss of electron. Cathode, there will be gaining of electrons. And then we add the 2 halves, we get the net, which we are saying is 3 marks. Now, from there we're going to say we're going to do what we call cell notation, which I've shown on the slide. On this slide, I'll show it here. We're going to refer to what we call the cell notation. Cell notation. So in the cell notation, we are saying A, B, C, which is our anode, the salt bridge, and the cathode. Remember how you found the anode? You said that one that was at the top of table 4b, the one with the lower standard reduction potential will lose electrons, and the substance that loses electrons, or the electrode where oxidation takes place, which is loss of electron, is the anode, and the salt bridge and the cathode. Then you know that is AB, ABC. So don't forget, for cell notation, we're saying ABC, which is anode, salt bridge, and cathode. So you tell us in the anode, we saw that zinc was losing electrons. In the cathode, we saw that copper 2+ was gaining electrons to form copper. So hence we said zinc becomes zinc 2+. Then we have the salt bridge. The salt bridge, we indicated with those 2 lines, and then we are saying copper 2+, and then gaining electrons to form copper. So this is another 3 marks. Remember, we had 3 marks of writing the net cell reaction. We have another 3 marks for writing the cell notation, and then that is how you go about writing your cell notation. So we're going to have a break now in a minute's time, and then we'll be able to come and take it from where we have ended. So I hope you have understood how do we determine which metal will lose electrons. We indicated that the substance with the low standard reduction potential will lose electrons. The one with the high standard reduction potential will gain electrons. We have indicated, you can draw your Z there between the 2 substances. The one where the arrow is going backward, it will be reversed, which is your anode. The one where the other one, it will be written as is, which is your cathode. We only write 1 arrow, we don't write 2 arrows. And then for net, we said what is on the left of your half fractions, you write on the left. What is on the right, you write on the right. For cell notation, we said you are going to use A, B, C. A for the anode, B for the salt bridge, and C for the cathode. You'll remember we talked to the salt bridge. We said this is the salt bridge. This is the salt bridge that we have, and when we come back, we'll be talking about the functions, how the salt bridge they work, and all that as we complete this galvanic cell. So I will see you when we come back from our break.
Dreams. What is your dream? Yini phupho lakho? Not your parents' dreams, not your mom's dream for your life. What is your dream? Is it to get a bursary? Is it to study science? Is it to become a DJ? Is it to become a singer? What is your dream? Iphupho lakho. Once you have that dream, what I need you to do, I need you to write it down. Ingole mofati. Write it down, ibhale phansi, and read it each and every single day when you wake up. Read it each and every single day before you go to bed, and remind yourself of where you want to see yourself. What is your dream? Write it down, meditate on it, and go after it with everything that you have.
The road to success, to becoming a successful student, is through commitment. Commitment to studying, commitment to putting in the extra hours in your books. I know it's not going to be easy. Actually, no one said it will be easy. But if you keep pushing, and if you keep believing a little, but if you keep pushing, and if you keep believing a little more in yourself, then the results will show in your life. The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Welcome, grade 12s. So we're saying galvanic cell, table 4b. What is this table? It's a table of standard reduction potential. Now, you will ask yourself, what is the meaning of the word potential? Potential means ability. It's an ability. When you say I have potential to pass, you are saying I have ability to pass. What is the meaning of the word reduction? Reduction means gaining of electrons. In terms of electrochemistry, we're saying this table 4b is the table of ability to gain electrons. ability to gain electrons, because potential is ability, reduction is gaining of electrons. So I want you to understand this table, because this is where our science, our electrochemistry is. If you understand this table, you have the memo in the exam. We are saying potential is the ability to do what? To gain electrons. Standard stands for what? Standard conditions. So we have standard conditions, which in this case, our standard conditions, we are looking at 3 conditions, which is our temperature. Temperature is equal to 25 degrees Celsius. And then we are saying concentration, which we can sometimes refer to it as initial concentration. So the concentration is 1 mole per cubic decimeter. And pressure is 1 atm. You can say 1 atm, or you can say 101.3 kilopascals. So we are saying these values that we are having here, these are standard reduction potential. These they were attained, or we got them under standard conditions. So zinc 2 plus 2 electrons forming zinc, we're saying the standard reduction potential is minus 0.76, but this is under standard conditions. So a question can come in the exam. What are the standard conditions applicable to this cell? For example, in this cell, we have zinc. I told you that when we have ions, you must know this is aqueous solutions. And then when we have no ions like that, we're dealing with metals here. So this is our solids metal, which we refer to as electrodes. Remember, we said our electrodes are solid because they must be good conductors of electricity. Now, what is important here is that we are saying this is the ability, which is the potential. It is the ability to gain electrons under standard conditions. So I was telling you that standard conditions is a temperature of 25 degrees Celsius. It's a concentration of 1 mole per cubic decimeter. It's a pressure of 1 atm. But if you check, pressure affects only gases. So we don't have a gas here. We have aqueous and solid. So you can't be mentioning pressure here. You will be mentioning temperature and concentration. So it's very much important, because in the exam we can say write down 2 standard conditions for this reaction. You will say temperature is 25 degrees Celsius. Concentration is 1 mole per cubic decimeter. You can't say pressure is 1 atm unless you have a gas, because pressure affects gases. So I hope I cleared this issue of standard conditions. To say standard conditions, you look what is involved. Do we have a gas? If we have a gas, pressure will be a factor. But if there is no gas, pressure is not a factor. You will name concentration, you will name temperature. And you must say how much is the temperature. You must say temperature 25 degrees Celsius, concentration 1 mole per cubic decimeter. Now, as I wrap up this part, to say this is the ability. So to do what? To gain electrons. Let's look between our zinc and our copper. What is the ability of zinc 2 plus to gain electrons? Remember, it's only the ions, the reactants, that can gain electrons here. So what is the ability of zinc 2 plus to gain electrons? We are saying it's negative 0.76. What is the ability of copper 2 plus to gain electrons? Is 0.34. So copper 2 plus has a higher ability to gain electrons than zinc 2 plus. Hence, we are saying copper 2 plus will gain electrons. Why? Because it has a higher ability to gain electrons. Zinc 2 plus won't gain electrons. Why? It doesn't have a higher ability to gain electrons. It's like a competition. So if you don't have the power, you won't be able to win. The one who's winning is the one who's more powerful. So we're saying copper 2 plus has more ability to gain electrons, which is 0.34. As compared to zinc 2 plus, that has a low ability to gain electrons. Hence, the one with the higher ability will always gain electrons, and the one with the lower electrons ability will lose electrons. So I think we've clarified the issue of why zinc will lose electrons and copper 2 plus will gain electrons. Remember, electrons are being lost by a zinc, which is your solid, but they are gained by the ion. So it's copper 2 plus that gains electrons, but it's zinc that loses electrons. So I hope you have understood that, and it will help us as we move forward. I've clarified the issue of oxidizing agents. They are on the left, and as you go down the group, the table, you will find that you find stronger oxidizing agent. And on the right, you have a weaker reducing agent here, but as you go up, you find strong reducing agent. So if you can check, the reaction is between strong reducing agent and strong oxidizing agent, which is zinc and copper 2+, which is shown here on the left. Our reactants is a strong oxidizing agent, which is zinc, and a strong reducing agent, which is zinc, and a strong oxidizing agent, which is copper 2+. So when you look for oxidizing agents, you go on the left, you look at the arrow. When you look for reducing agent, you go to the right, you look on the arrow. So you are able to do that. So all the time, the reaction is between strong reducing agents plus strong oxidizing agent. I hope you got that. In this case, strong reducing agent, according to this arrow, is zinc. In this case, strong oxidizing agent, according to this arrow, is copper 2+. Hence, on the left, we will have a strong reducing agent, which is zinc, and a strong oxidizing agent. So all the time, you will have a strong oxidizing agent and a strong reducing agent reacting together to form the weak reducing agent, the weak reducing agent and the weak oxidizing agent. So don't forget that all the time it will be strong and strong on your reactant side. I hope I've done that correctly. And then we have another question now that says calculate EMF of a cell, E of a cell. You will go to the data sheet, you will find the formula that says E of a cell is given as E cathode minus E anode. Please copy the formula as it appears in the data sheet. Don't change anything. And we're simply saying it's a bigger number. Remember, you said A and C here. You said the first one is anode and the second one is cathode. So don't forget that we are saying the first, we start from A to C. So the anode is at the top of table 4B, the cathode is at the bottom of table 4B. So when you say cathode, you just go to the bottom and say, oh, we have 0.34, that is our cathode, 0.34. Our anode, don't forget to write this negative that is on the data sheet. And then our anode is negative 0.76, so you write negative 0.76. Just use your calculator, then it will give you an answer of 1.1 volts. And because it's positive, we say this is spontaneous. But if the answer is negative, we say it's non-spontaneous. So I'll go to the page where we have shown this calculation nicely. In this case, the calculation of the EMF, this one. To say you chose the formula E of a cell is equal to E cathode minus E anode. You substitute the cathode, we said it's the bigger number, which is 0.34, and then the smaller number is the anode, which is negative 0.76. Then if you use the calculator, just punch this number the way they are written. You don't even have to use anything. The calculator will solve this issue for us. Just write 0.34 minus 0.76, and then you say equals to, it will give you 1.1. Don't forget the SI unit for our EMF is volts. So E of a cell is in volts. You are able to do that. In the data sheet, you have 4 formulas that we use to calculate the EMF, which is E of a cell is E cathode minus E anode, the first one. E of a cell is E reduction minus E oxidation. And the E of a cell is E oxidizing agent minus E reducing agent. These 3 formulas, they can help. Let's say you have forgotten. We are asking you a question. For example, we are saying which one is the oxidizing agent. So oxidizing agent, you will know that the oxidizing agent, look on the left of these formulas. Oxidizing agent is the substance that undergoes reduction, or is the cathode. So you just go and check the cathode. Remember, we said the bigger number there, which is your more positive number, is your cathode. So you just go and check which one is your cathode, which is your oxidizing agent. Then you know that, okay, which one is your anode. You know that your anode is where oxidation is taking place. We said anode is the electrode where oxidation is taking place, and then that is where you find your reducing agent. So I hope as and when you think you have forgotten some of these definitions, you will go back to this table of data, and it will help to remind you to say, okay, if I'm looking for a cathode, what am I looking for? I'm looking for the electrode where reduction takes place. So it means for definitions, we have given you the definitions on the data on that table to say a cathode is an electrode. Remember, a cathode is an electrode where reduction occurs. What is the anode? It's an electrode where oxidation occurs. And then what is a reducing agent? Same thing. You say a reducing agent is a substance. Remember the key word there. For reducing agent, you are talking about a substance. For cathode, you are talking about electrode. For oxidation and reduction, you're talking about electrons, whether they are lost or gained. So it's important for you to remember to say when you say what is a cathode, you'll say it's an electrode where reduction occurs. What is the anode? It is electrode where oxidation occurs. What is oxidizing agent? It is a substance. So I hope on your data sheet you are writing this to say, okay, when we say oxidizing agent, we know oxidizing agent and reducing agent are what? They are substance. So when you say what is an oxidizing agent, you are saying it's a substance. What is happening with that substance? The substance where it's a substance where reduction occurs or takes place, and then a substance that undergoes reduction. So you must know that it undergoes, an agent undergoes. So we're saying a substance that undergoes reduction. So that is your oxidizing agent. A reducing agent is a substance that undergoes oxidation. I think I've given you a lot. You will be able to remind yourself of these questions, of this method of using table 3 to answer the questions. So you can define a cathode using this data sheet, because you also, what is a cathode? You say it's an electrode. You check, electrode where reduction occurs. You get that mark. What is an anode? It's an electrode where oxidation occurs. You got that mark. What is oxidizing agent? It's a substance that undergoes reduction. Is an oxidizing agent. And then what is a reducing agent? It's a substance that undergoes oxidation. So I think in terms of those formulas, you will get there. Even in terms of using this data sheet, we are saying you copy as is. You don't do shortcuts and you say E of a cell equals to E hat minus En, because remember this formula is given for free. If you are unable to go and copy it the way it's written, definitely you're going to lose marks. So I say, please, when you copy it, copy the way it's written on the data sheet. And then we say ANC. The first one is your anode, and then the second one, which is your cathode. So you are able to remember that, okay, we have the anode, which is that small number, and the cathode, which is a big number. And the other thing which is important, I think I must remind you here, is to say when you are having two positive numbers, let's say you are having 2 and 4, for example. I'm just using this 2 and 3 as an example. You will ask yourself which one is the positive number, which one is the negative number. You will know that if you have a number line, the number closest to the negative would be +2, which means the +2 becomes your anode. The cathode is that bigger one that is more positive. So your cathode is more positive as far as galvanic cell is concerned. We'll talk when we come to electrolytic cell to say how do you apply these principles. But at all times you will be able to. So we have the anode and the cathode. The anode being a negative electrode. So between two positive numbers, you still have a more negative number and a more positive number. I gave a nice example between 2 and 3. Positive 2 will be more negative than positive 3. So you will expect that if you have a substance that has a standard reduction potential of +2, definitely it will lose electrons. The one that is +3 will gain electrons, because we said standard reduction potential stands for ability to gain electrons. So the one with the big ability will gain electrons. I hope you followed that, and you will be able to calculate the EMF without no problem, and you will get all the 4 marks. Remember, you get the mark for the formula, which you're copying from the data sheet, the mark for the cathode, which is your bigger number or the more positive number, the mark for your less positive or negative number, and then you mark for the final answer. And when it's positive, you know, we said this is spontaneous. So it's self-sustaining. No energy need to be added. I hope you will collect marks for EMF. It's not many questions that we have that does not ask you to calculate the EMF. So you will do that. The issue of the cell notation I've talked to. I wanted to, before we go to questions, to say there are changes that takes place. There are changes that takes place on the electrodes. Remember, we said zinc is the anode. It's in the anode. And there is loss of electron where zinc is. So when zinc loses electrons, what will you see? You will see it will decrease in mass. So you can see zinc, it decreases in mass. Copper, our famous metal in this country is copper. And then you can see that copper 2+, when it gains electrons, it increases in mass. So you can see that's the first thing. We can ask you which electrode will increase in mass, which electrode will increase in mass. So you know the one that is losing electrons, which you said is the small one, which is our anode. We're saying the anode, when it loses electrons, it will decrease in mass, but the cathode, when it gains electrons, it will increase in mass. So I hope that helps you as well. Now, the other thing that is important is what I'll be going to now. So, okay, this is a physical changes that we can see there. Now, let's look at the electrons. Because we said zinc, this side, we have zinc. Zinc is going to lose electrons, meaning that the electrons are moving from zinc. They are going that side, electrons. Those two electrons, these two electrons that you see here, they are moving, they are leaving this place. They are moving to that place. But I just told you that the zinc, because it's losing electrons, it will decrease in mass. So you know that, okay, the one that loses electron decreases in mass. What happens? The electrons are coming this side. Usually, we'll have a voltmeter there, which will read 1.1, unless otherwise the concentration has decreased. Remember, we can only have EMF of 1.1 volts that we've calculated there, as long as the concentration is 1 mole per cubic decimeter. But the concentration will definitely change, and as the concentration changes, we'll expect the EMF to decrease. Now, zinc loses electrons. The electrons, they move. You see where the electrons move? They move on this one. We refer to it as an external circuit. So they move from anode electrons, they come in to the cathode. They don't end up on the copper itself, the solid. No, they are coming to react. Remember we said here in the solution we have copper 2+. So as the 2 electrons are lost by zinc, they go, these 2 electrons, they are going, they move, they come this side. They are going to react with what? With copper 2+. So you'll expect that copper 2+, because it's busy reacting with the electrons that are coming from here to form copper, which means copper. This copper will increase in mass. This zinc is losing, it will decrease in mass. So on the cathode, there will be increase in mass. On the anode, there will be decrease in mass. But in terms of the solution, zinc is forming zinc 2+. So this solution will increase. So we say the concentration of the zinc 2+ or electrolyte will increase. In this case, the concentration of the copper 2+ concentration will decrease because it's busy reacting the electrons from there. So you are expecting this copper 2+ to decrease, this zinc 2+ to increase. I hope you got that. And you have seen how the electrons flow. So they flow in the external circuit from the anode to the cathode. So we'll ask you, where will the electrons flow? You must know they must always move from that smaller one. That one in table 4b, that one at the top of that table is the one that is going to lose electrons. And that one at the bottom of that table, which is the one with the high standard reduction potential, is going to gain electrons. So there will be decrease in mass, increase in mass. And in terms of the solution, if there is a decrease in mass, you must know that the electrolyte concentration will increase. If there is increase in mass, the electrolyte concentration will decrease. I hope you got that, and you know that the electrons, they flow from the anode to the cathode on the external circuit. Now, if there is external circuit, you're expecting that there will be internal circuit. That brings us to our next slide, which is the salt bridge now. You see, electrons are moving from the anode to the cathode. But now the ions themselves, what is happening to the ions? Remember, in the salt bridge, you'll forgive me for writing 2 salts there. Let's say our salt in this case is potassium nitrate KNO3. Now, if this is the salt, remember the salt, it has positive ion and negative ion. So you'll remember the positive ion is what we call the cation. Some they say cation. It's fine, cation. And then the negative one, we call it the anion. So please don't forget, Leonard. Remember, we said the one that is losing electron, that is our anode. So anion or negative ions, they will come to the anode. The cation goes to the cathode. So don't forget, cations to the cathode, anions to the anode. So you know that the negative ions, this one is negatively charged, it goes to the anode. So when you see anode, you see that, oh, it's a negative ion electrode. Negative ions goes to the anode in the internal circuit in our salt bridge. So the salt, that's what the salt bridge is happening. Hence, will ask you in the exam to say, write down the functions of the salt bridge. So you will be able to say, okay, in the salt bridge, what is moving? It allows movement of ions. You can see anions to the anode, cations to the anode, cations to the cathode. Now, why are these ions moving? Remember, electrons are leaving here, they are going to the cathode. What happens is that it leaves here with more positive, because negative is going, it's moving. 2 electrons, they are moving like that in that direction. We said it moves in the external circuit. But what is happening is that it's leaving more. We said this solution is increasing. So we have more zinc 2 plus that is being formed. That's why NO3 minus is coming here. Why is NO3 coming? To maintain neutrality. Sometimes we'll say to maintain electrical neutrality. And then on the cathode side, what is happening? We know that the electrons are busy coming here. So there are more negative that are coming here. Hence K plus or potassium ion, which we call cation. Cation to the cathode is coming to do what? To maintain neutrality. So these are the functions of the salt bridge. Number 1, to complete the circuit. Number 2, to maintain neutrality. How does it maintain neutrality? It allows movement of ions. So you can see in the salt bridge is the ions that are moving. In the external circuit is the electrons. So don't confuse the movement of electrons and movement of ions in that order. So I hope this will help you as well to know that in the external circuit, there are electrons that are flowing, but in the internal circuit, which is our salt bridge now, in the salt bridge, there are ions that are moving, and cations moves to the cathode and ions move to the anode. I think I have emphasized, and you will definitely remember that as you write your exams. I talked about the cell notation. I talked about the EMF. You have seen how this data formula sheet is going to help us to remember these definitions. So I don't expect any of you to be getting definitions wrong, because we are saying everything is given to you, you just go there. Now let's go to the summary before we can start doing our questions. Then we'll be able to go to our questions, and then we can move forward with no problem. So summary, we are saying, what is the anode? So we are saying the anode. Remember, these are your notes. You will use them to revise. The anode, we are saying, is where oxidation takes place. It's where oxidation takes place. Hence, I said an ox. You can just remember it like that. What is the anode? Is the electrode where oxidation takes place. What is the cathode? It is the electrode where reduction takes place. Hence, we're saying red cat. So don't forget those two things. Saying it's an ox and red cat. And we said an ox is reversed, it goes backward. Red cat is in the future. So you know, in the past we used to trade with cows and cattle and all that. So we are saying it's an ox. Then you know, anode it's reversed. It's instead of backward, it goes backward. When you talk about ox, you are going that side. But when you say red cat, we are yet to have red cat, and then red cat in the future. So the reaction goes forward. I'm just saying that so that you can remember what we're saying. And anode, you can take it from there. An anode is a negative electrode. It's negative. So this one is the negative, like you saw negative 0.76 for zinc. You have seen positive electrode, positive 0.34 for copper. Who are moving together. So you know that the anode will have a lower, the one with a lower number, lower reduction potential is our anode. The one with the high reduction potential, like copper 2 plus, is in the cathode. But remember, I said anode and cathode, they are solids. They are solids. Anions, they move to the anode. I told you that. Anions to the anode, cations to the cathode. I use potassium nitrate as an example, where NO3 minus was moving towards the zinc 2 plus there, towards the zinc upcell, and then we had K plus that was following the electrons to the cathode there. So you are able to see that. The anode, we said, this one because it's losing electrons. When you lose something, then you are decreasing in mass. So the solid corrode, and in the cathode, it increases in mass because it's gaining, the copper 2 plus, we're gaining electrons. And then we already said that this is a negative electrode, this is a positive electrode. We talked about the substance that loses electrons, a substance that loses electrons, or the substance that is undergoing oxidation is our is our reducing agent. It is found at the anode. The oxidizing agent is found at the cathode. Just bear with me there. It is at the cathode. So I hope this summary will help you. And as we move, energy tips now to say in the exam, say how will this help me? How is this going to help me as I'll be writing my coming exam? The first thing that we must remember is that talk to energy conversion. Remember, when you define galvanic cell, you'll say define galvanic cell. You'll say, okay, I'm going to talk about energy conversion. It converts, it's a cell that converts chemical energy to electrical energy. Then you get that correct. What are the functions of the Salt bridge? I told you that the Salt bridge allows the movement of ions. Why? Because it wants to maintain electrical neutrality. It wants to complete the circuit. So you remember that, you get that. So movement of cations and anions, already we talked about it. To say cations, they will move to the cathode. Anions, they will move to the anode. The standard conditions, we said, okay, there are 3 standard conditions. It's our temperature of 25 degrees Celsius. You will write the temperature in full. It's our concentration or initial concentration of 1 mole per cubic decimeter, and we said pressure of 1 atm or 101.3 kilopascals. So you are able to remember that to say 1 atm. So pressure affects only gases. You will write pressure when you have gases. You know how to identify the anode and the cathode. I gave you the table to say, okay, our anode is that one that you will find at the top of that table, our cathode at the bottom. Or our anode, it has a lower standard reduction potential. Our cathode has a higher standard reduction potential. So at our cathode, we don't change, there's no reversing of direction. You write it as is, and then you just write single arrows. I indicated and overemphasized that you can't write 2 arrows. It's 1 arrow as you are writing your answers. We talked about what is the oxidizing agent, the reducing agent. I've shown you how to use the table, the table for EMF equations to answer such questions. I have as well used the loss of electron is oxidation. The reducing agent is oxidized, the gaining of electrons is reduction, oxidizing agent is reduced. So you can always refer to that. How to write the net cell reaction? So you write the oxidation half reaction, reduction half reaction, and then you are able to cancel the electrons. And then cell notation, we said we use A, B, C. And on your anode, for example, we said zinc, it becomes zinc 2 plus, and salt bridge, and then salt bridge, then we have copper 2 plus, forming copper. So that's how we write. So always check that you have solids outside here. You have solids at the ends of your cell notation. Calculation of EMF, we said E cathode minus E anode. Copy the formula as it's written, and then write. You always say bigger number minus smaller number. And then for this galvanic cell, we're expecting a positive answer. And then it must be in volts, because if you don't write the SI units, you will lose that marks. I've shown you that the oxidizing agents are on the left of the table 4B, and then the reducing agents are on the right. And as you go down the table 4A, 4B, you are able to see that the strength of oxidizing ability is increasing. So stronger oxidizing agents are the ones you will get at the bottom. However, at the top of the left there of your table, you will find weaker oxidizing agent. However, on the right, we are saying we have our reducing agents, and stronger reducing agents are at the top where we had zinc there. And at the bottom where we had copper, we find our weak oxidizing agent. So I hope you have understood all this. As we do our activity, is just taken straight from a 2020 examination. You can see now, as we give you this, we are studying the cell notation. Now, Elena, who has been in this session that we are in and who has been attending even at school, will know that, oh, this is cell notation. Remember what we did in cell notation? We said A, B, C. So it helps you to remember that, okay, A is the anode, is B is the salt bridge, C is the cathode. So this is going to help you directly now on what we're doing. Remember what I said. I said energy conversion is the first thing that you must remember. So how does this help you? Define galvanic cell. So you know energy conversion. Oh yes, said this one is a cell, because galvanic cell is a cell. So you'll say it's a cell that converts. So you tell us about energy conversion. That is a cell that converts chemical energy to electrical energy. Then you write it nicely in full, and then you are getting your 2 marks. You see the importance of remembering that. Draw a level diagram. You see now, on the activity that the examples I've used, I gave you the diagram, but the question can come and say, draw the diagram. So we told you that we have two beakers here. So you will write two beakers. We said we have two metals. We have two metals. And then you will draw the two metals. You said, okay, we have zinc, we have copper. Leonard, I don't want you to cram to think that zinc will always be on the left, copper on the right. No, we can interchange them in the exam. Then we said they must be matched in their solution. So if you have zinc, the solution must be zinc 2 plus or zinc sulfate. If you have copper, it will be copper 2 plus or copper sulfate. So you're able to draw that. Already you got a mark. We said we must have a salt bridge. Then you draw your salt bridge as well. And you are indicating that the electrons will move here. The electrons will move here. You indicate that in the salt bridge, we have the cation and the anion. And you said anion to the anode, and then cation to the cathode. Then you are able to draw your structure. I hope you will get you 5 marks there and be able to celebrate. Write down 2 standard conditions. It's not by mistake that we said 2 standard conditions. Remember, pressure affects only gases. Hence, we are saying 2 here because there's no gas. So you are able to say, okay, told us, we said temperature in full is 25 degrees Celsius or 298 kelvins. It doesn't matter, but it's better if you understand 25 degrees Celsius. It's better to write it like that. Initial concentration, we said is 1 mole per cubic decimeter. Look at the beauty of that. You are collecting your marks now. To which half cell do N ions? You see now the questions that we talked about. N ions, where will they go? Remember, we said N ions to the anode, cat ions to the cathode. So you are able to answer that question with no problem. So explain the answer to 6.1.4. Why are you saying to the anode? So you know that, okay, the anode, for example, we had our zinc in this case, which was zinc forming zinc 2 plus 2 electrons. So you'll be able to say, okay, in the salt bridge, the salt bridge allows the movement of ions. Why? To neutralize. Why the anions coming here? Remember, anions are negative ions. They are coming to neutralize because we're having high concentration of zinc 2 plus. So they are coming to neutralize that positive. Remember, when you have more positive to neutralize it, you need a negative. That's why an anion is coming to neutralize that. So you are able to respond to that question with no problem. Then we have our last question here, which is this one that you are seeing here. We're saying the anode in the zinc copper cell is replaced by an unknown electrode. You see now, it's a little bit of a math. Now we'll need your math to say now we knew what we had. Now they are changing only one thing. What are they changing? They are now changing. They say, okay, we had a zinc copper. Remember zinc copper, we said EMF is 1.1 volts. We've calculated it together. You remember that. Now they're saying, okay, in this zinc copper cell, we are going to replace the anode, but the anode, which is zinc. So zinc is replaced by another one that we don't know, but the EMF, the E of a cell is given. I think we know that E of a cell is equal to E cathode minus E anode, E cathode minus E anode. So it looks like a difficult question, but it's just about application to say, okay, E of a cell is given. We have 2 here. We have 2. And for copper already, you know that for copper is positive 0.34. We've been doing that. You will remember. Positive 0.34. But now, so the only thing is that it's either you are adding 0.34 to 2 or you are subtracting 0.34 to 2. Then you know that you are able to get your answer. Then if now you were to go to the table of standard reduction potential and you are going to look for 2.3, if you add 34 on 2, you'll get 2.34. Then your table will be able to tell you whether you are able to have 2.34 or not, which you don't. And immediately when you say 2.34 minus 0.34, and then you just take your calculator. If I can use my calculator, that will give me 1.66. And then you go to the table of standard reduction potential, you look for that element that you are having with that standard reduction potential. So I hope that helps you as well to say, okay, fine, we had 2,0. We had our copper, which was 0,30. Let me do it so that we don't just guess it. So it's 2,00, and then we have 0,34. So what is happening is that if you have E cathode, if your cathode is 0,34 minus, remember it's minus anode that we don't know, E anode or E anode there that we don't know. Then as we bring this one this side, it will be 2,00 minus 0,34. That gives us minus E anode. E anode is what we are looking for. And then 2 minus that is 1,66. But we have a negative sign here for the E anode, remember? And then you bring the negative that side. You have your E anode equals to negative 1,66. So negative 1,66, if you go to the table of standard reduction potential, that will be, I think it will be your aluminum. Yes, as I checked there, then you go to the table, you are able to identify your aluminum. So you are able to get your 5 marks. But the most important thing is that you know that how to write the formula E of SL. E of SL, I'm trying to check time as well. E of SL is E cathode minus E anode. So you have got already that 1 mark of writing the formula. Whether you're going to get it correct or not, you know that E of SL is given as 2,00. Already got another second mark. You can see how to collect the marks now because E of SL is given is 2,00. So you write that. Then you have your E cathode, which was your 0,34. Remember, they only replace the anode. So you have minus E anode. So you got another mark for writing that. Remember, you have 3 marks already. You transpose, you are taking 0,34 this side. So it's 2 minus 0,34. That gives you minus E anode. So you have your minus E anode, which is, in this case, don't forget this 0 at the top of the E there is very much important. We said E anode is minus 1,66 volts. You go to the table, you look for it, you will get your aluminum. Then you are able to get another mark for getting that minus 1,66, another mark for getting that is aluminum. Then you are able to get your 5 marks. You are smiling. Write down the operation that takes place at the anode. So you know at the anode is aluminum. Now we just go to the table, you are looking for aluminum. You know at the anode we lose electrons. You look for the aluminum on the table, and then you will write aluminum losing 3 electrons. Then you are able as well to get 2 marks. Which electrode will express a decrease in mass? Remember, the one that loses electrons will decrease in mass. So you're able to say, okay, aluminum will decrease in mass. Explain the answer to question 6.2.3. So it's the same as you indicated there, that aluminum will lose electrons. So as aluminum loses electrons, as it loses electrons, it will decrease in mass. So a substance, which is the aluminum, is the anode. So the anode will lose electrons and it will decrease in mass. You know that it is the anode that decreases in mass. So I think once you have this type of questions and you practice them all the time. So what is important? What do you get from these questions that we're doing? You get that the questions, we won't always start by giving you a galvanic cell. No, in this case, we started by giving you the cell notation. The other question, we can start by giving you the overall, which is zinc. We said is zinc plus copper 2 plus forming zinc 2 plus copper. You see, so you must be able to know that you are able, as a wrap up, you are able, we can give you this, the overall or the net cell reaction. So what you have to do is to check it. Okay, we're starting with zinc is becoming zinc 2 plus. You see that this is loss of electrons. So it's zinc becoming zinc 2 plus 2 electrons. You have copper 2 plus becoming copper. You know that the ion is the one that gains electrons. So you will be able to say, okay, this is copper 2 plus 2 electrons forming copper. So please, learners, understand, don't cram the question. Do many questions. Ask your teachers at school and practice as many problems as possible. But I'm telling you, if you do this correctly, you do your PET correctly, and you understand, you're able to answer those questions, you practice them, you sit on them, you will do very well as far as this galvanic cell is concerned. And they're just level 1 questions. For example, we had a question that say, write down 2 standard conditions. You just have to remember. We had a question that say, define galvanic cell. Draw a leveled diagram to represent the zinc copper cell. So such things, already we said N ions will move to the anode, cat ions will move to the cathode. So you are collecting those marks. And then the other thing which is important is the EMF calculation. So we're saying it's not all the time that we'll say calculate EMF. No, we can give you the EMF of a cell and give you a cathode or an anode, and then we ask you to do what? To calculate the other one, to find out which other one. Your job, as we have done with this one, is to go and do the math and do the subtraction and go back to the table and refer and be able to identify which unknown, metal that were given. So I hope this session was beneficial to you, and you can say with no doubt how to use the table of standard reduction potential. We're saying the one with the higher standard reduction potential, it does not change. You copy it as is, but the one with the lower standard reduction potential will definitely lose electrons. I hope if you have done that, you know all what you have done, and I would like to thank you very much and hope you will do a lot of other activities and revision. And to borrow from Nelson Mandela, he said, it is in your hands to create a better world for all who live in it. I hope these ways will encourage you to go and practice and prepare and do very well in galvanic cell. Thank you very much.